Hey guys, what's going on? I wanted to do a quick video today talking about the vortex value and some of the ways that I went about developing this idea from the get-go, and just some of my techniques and methodologies that I used. Titled The Development and Operational Utility of an Experimental Tornado Forecasting Index. This is something actually that I presented last year at a class that I had at UAH. And we'll go through the whole thing and just kind of talk it through. So since the early 1970s, operational meteorologists have used composite indices to assist them in the assessment of overall pre-storm tornadic environments. Composite indices feature several critical ingredients that have been identified as being crucial for the development of severe thunderstorms and their tornadic counterparts. This investigation analyzes the development of a 5-parameter tornado forecasting index, hereafter referred to as the Vortex Value, Experimental Tornado Forecasting Index, or simply the Vortex Value, which the research for which began in February of 2016, just prior to the start of the Vortex Southeast field project, in which myself, the author, served as a lead forecaster. Statistical analyses were performed to better understand the relationship and operational utility between the vortex value, the enhanced Fujita scale rating, and 5 frequently used composite indices used by the meteorological community, such as STP, SWET, EHI, Craven-Brooks, Severe Index, and the vorticity generation potential. We'll go into more of those in just a sec. So a little background for you here. Composite indices, again, were compared to the vortex value during this study. A significant tornado parameter from Thompson et al. 2003. Energy Helicity Index from Hart and Krotke 1991. The SWET Index from Miller 1972. And as I mentioned before, Craven-Brooks Severe Parameter. This is from Craven and Brooks 2004, and the Vorticity Generation Potential, or VGP. This is from Rasmussen and Blanchard 1998. All 6 of these indices were statistically compared to the enhanced Fujita scale ratings for 82 tornado cases to date. So here's some of the methods that I used to develop the vortex value. The National Climatic Data Center Event Database was used. University of Wyoming Sounding Archive, that's a very popular one. Has a lot of soundings there. Go check that one out, it's a good one. Storm Prediction Center, the Mesoanalysis Archive that they have is fantastic as well. Also, as well as the SPC Thunderstorm Event Archive and the NOAA RUC Interactive Sounding Database. This was used, I mostly used this to grab some point soundings for the RAP-RUC from the past 15 years, and to try to better understand the environments in which these storms formed. Only tornado cases located within 120 kilometers and a temporal span of 4 hours were selected in an attempt to preserve accuracy and timeliness of the data. The Lorentz equation was utilized to estimate LCL height. In cases, I might add, only in cases where solometer observed cloud base height was not available. So the Lorentz equation is a good estimate of cloud base height. For those of you who may not know, in proxy of or in place of solometer observed cloud base height. So only when you don't have those solometer observations or a proximity sounding, should you use the Lorentz equation. Because if the atmosphere is not well mixed, then your estimate is going to fall short of the actual observed cloud base height, and that's going to vastly affect your calculations. Also below, wonderground.com was used for easily access to surface data archives, as well as was the NCDC Surface Archive. And you can get to that by going to Google and typing in 5-minute ASOS, ASOS, and that'll pull up the archive that I used. Some advantages of the vortex value. This was shown to be more statistically robust than other tornado forecasting composite indices, the 5 that I previously mentioned. Often accurately represents tornadic potential missed by these other indices. It has shown to be very valuable in assessing the top end or ceiling of tornadic potential for a given event. It requires a thorough diagnosis of both the current state of the atmosphere and an accurate projection or forecast of conditions to come. This is really critical, and we know how highly variable the atmosphere can be with regards to space and time. So that's the real trick here, is to estimate what you think the atmosphere will be in a few hours. And we'll talk more about that shortly. It helps guide the forecaster to a better understanding of the state of the atmosphere and has an impressive success rate for predicting the full spectrum of tornadoes from weak to violent in many cases. Some disadvantages. No composite index will really ever be perfect, as you know, due to the nature of the atmosphere to be unpredictable or uncertain. Each of the 5 terms in the equation are rather sensitive and can vary widely in forecast models. And they can be inaccurate, if either human interpretation is wrong or the model data is wrong. The index requires a forecaster with operational forecasting experience to run the numbers. This is true most of the time. Now that I've worked with it, played with it for a year, there are many times too where it's also right on. You can just use the model data values straight from the data. In fact, for instance, the point and click SKU-T, you could just use that data straight up and not modify it to get these values sometimes. But you must understand that sometimes that's not going to work very well. This is not meant to be a canned formula, of course, and was designed to help forecasters all over the globe learn the flavor of tornado days. I think that's the thing that I really meant, was that third bullet there. That was really my intention when developing this index. And I think it still helps a lot. You just have to be careful how you use it and use the right methods to gather the data. There could potentially be a substantial learning curve when first attempting to use the vortex value operationally. However, it is an extremely valuable teaching tool as one learns how to use it. An atmospheric sounding should be available for the value to be as accurate as possible. Some of the values are highly sensitive that go into the calculation and should only be measured with a sounding. However, values can be augmented with use of mesoanalysis data, as the atmosphere often changes rapidly within the severe storm environment. I'll be honest, a lot of times I don't use a sounding now. The only thing that I'll really use it for is for estimating the boundary layer relative humidity, and to determine, obviously, along with that, whether or not we've fully mixed in the planetary boundary layer. So here's a correlation coefficient chart showing the results and the robustness of the statistical analyses performed. The correlation coefficient chart indicates a very strong correlation between the vortex value and EF scale rating for all 82 tornado cases across all regions. You can see how much higher the correlation coefficient is for the vortex value as opposed to all the other 5 parameters analyzed. The other 2 that were next highest were significant tornado parameter, STP, and the vorticity generation potential, or VGP. And it was over 0.25 correlations higher, or 25% higher than the nearest neighbor. So here's some more results. This is a multivariate and univariate analysis that was performed. Pretty interesting stuff here. You can see that the vortex value certainly has it has statistical robustness. I didn't perform a ton of statistical analysis on this stuff, but those that I did perform indicated there's a lot of potential here. And the results, this is one of the more simple charts I have, just a simple box and whisker plot to show you how well it generally works, and that there's not a lot of overlap. If you can see, EF0, the top end on that peaks out at about where the bottom quartile, the lower quartile starts. And it kind of just goes on up the ladder as such, roughly. There's more overlap up in here in places, but you still have a lot of just power of discrimination, especially at your bottom ends, at the top and at the bottom. This, of course, would be no Tor, non-Tor, and a lot of these others in between have strong power of discrimination as well. So it works out really well. It's a strong index. Here is the front page of the assignment that was due for my, I think it's ATS 682 at UAH statistical analysis that Dr. Philip Bitzer teaches. It was a good class. I learned a lot, and we got to do this study as my final project. I really enjoyed doing this. It was fun. So some conclusions. As is the case with all composite parameters, the vortex value has strengths and weaknesses. However, it does stand up very well to robust statistical analysis and has proven very successful in an operational setting. It is up to the discretion of the experienced forecaster to properly use composite indices with caution in order to avoid potential pitfalls. Both correlation coefficient and regression analyses worked well to display the operational utility of the index. As I had mentioned before and I showed the charts, it does well. The index has demonstrated an ability to perform well under both high cape low shear, or HCLS, and low cape high shear, LCHS, events that are often experienced at various locations in the U.S. yearly. This is one of the main ways in which the vortex value outperforms other composite indices, especially in the realm of high shear low cape, which we study here in the southeastern United States. I've noticed in a lot of cases, of course, our high shear low cape events a lot of times happen at night, and what is normally regarded as very low instability or low buoyancy events, obviously with the low cape. But the vortex value compensates for that using precipitable water, which captures potential instability release in the atmosphere. I don't want to get off in the weeds too deep with that, but a good paper to read would be Sherburne and Parker from 2014 is a good paper to read. It's concerning high shear low cape events, and you'd learn a lot from that. I know I did. So it's a good paper. This talk and developed index was enthusiastically received by graduate students at UAH during presentation for, again, as I mentioned, our ATS, or Atmospheric Science 606 Data Analysis for Atmospheric Scientists class. It was very well received. I got a lot of questions, a lot of comments. Our instructor, Dr. Phil Bitzer, actually had to cease the comments in the questions because I was getting so many. Unfortunately, I think I had to leave 3 or 4 people stranded that had questions. But I believe I sought them out after class and was able to answer their questions after the class there. So that was good. But anyway, it was very enthusiastically received, which got me really pumped about it and was just good. So next to the bottom there, continued operational testing and broadening of case studies will continue. There's a couple of ideas that I have to improve this vortex value even further. I have observed several null cases where the index failed. It said that tornadoes were possible, and they actually did not happen. Of course, that's going to be hard to always pin down, but I have a couple of thoughts ongoing that I'm wanting to work with, mainly after I graduate from UAH, coming up here at the end of 2017 in the summer. Probably in August 2017, I'll be finished with my master's degree, so that's encouraging. And we'll be able to work more with the vortex value and develop those additional ideas to improve it even further. It is with great hope that this tornado forecasting index will help save lives, because that's what really matters, right? When at the end of the day, as a researcher and operational forecaster, if I can't in some fashion help someone, protect life or property, or just help stay well, then I'm not doing anything for the science of meteorology at all. As of right now, I work for UAH as a graduate research assistant, and I'm not real sure what's going to happen when I graduate, but I will certainly continue to pursue meteorology. It's my passion, and continue to develop this index. So thank you so much for listening. And if you have questions or comments, just holler, just let me know. Y'all take care.